we will see about Newton's lens equation. In case of Newton's lens equation, suppose there is a lens given in this ray diagram. ABC is one of the surfaces of the lens. ADC is another surface of the lens. When light ray coming from the object incident on the surface ABC, which is parallel to the principal axis, and one of the light ray simultaneously coming from the object passes through focal point F1 at the left hand side of the lens ABCD. Further, that light ray incident on the surface ABC of the lens and passes through the lens parallel to the principal axis. One of the rays which was earlier refracted passing through the focal point F2 at the right hand side of lens, and another light ray simultaneously which was traveling both the mids at this point forms image I. Further, so whatever the focal length F1 left hand side of the lens and whatever the focal length F2 right hand side of the lens. Further distances are extended x1 and x2, especially in case of Newton's lens equation. Instead of considering distances u and v, that is the object distance and image distance, they are extended from focal lengths left hand side x1 and towards the right hand side x2. In the ray diagram, from the ray diagram, h1, this h1, divided by x1, this x1. So this length h1, this height h1, further this height h1, h1 divided by x1 is equal to this h2 divided by f1. This h2 divided by this focal length f1. This focal length f1. Further, h1 divided by f2 is equal to h2 divided by x2 from the ray diagram. h1 divided by x1 is equal to h2 divided by f1, which gives us h2 divided by h1 is equal to f1 divided by x1. Similarly, h1 divided by f2 is equal to h2 divided by x2 gives us h2 divided by h1 is equal to x2 divided by f2. Further, h2 divided by h1 is equal to f1 divided by x1, which is equal to h2 divided by h1 is equal to x2 divided by f2. It gives us f1 divided by x1 is equal to x2 divided by f2. That gives us x1 into x2 is equal to f2 into f1. Further, x1 into x2 is equal to f2 into f1 gives x1 into x2 is equal to f square, where f1 is equal to f2 is equal to focal length of the lens, and that is why x1 into x2 is equal to f square. This is nothing but the Newton's lens equation. Further, we will see about the magnification of lens. Magnification is denoted with the letter small m, is the ratio of size of the image to the size of the object. Types of the magnification are lateral magnification, longitudinal magnification, and angular magnification. So now we will see one by one. Lateral magnification or transfer magnification, it is the ratio of the length of the image to the length of the object. Both lengths are perpendicular to the principal axis. Here m, that is the magnification, m is equal to h2 divided by h1. The lateral magnification corresponding to Newton's formula, and which is given here, m is equal to h2 divided by f1, sorry, h2 divided by h1 is equal to f1 divided by x1 is equal to x2 divided by f2. Now we will say about the longitudinal magnification. It is the ratio of an infinitesimal axial length in the region of the image to the corresponding length in the region of the object. Thus, if dx I and dx0 are extension of the image and object along principal axis respectively, then longitudinal magnification of the lens is given m suffix capital L is equal to dxi divided by dx0. So differentiating equation, that is the Newton's lens equation, x1 into x2 is equal to f square. So ml is equal to minus f square divided by x0 square, which is equal to minus m square. Now we will say about the angular magnification. Angular magnification is the ratio of the slopes of emergent ray and the conjugate incident ray with the principal axis. If the incident ray and the conjugate emergent ray make an angle θ1 and θ2 with the principal axis respectively, then angular magnification is gamma is equal to tan θ2 divided by tan θ1. So this is about the angular magnification, and these are the three types of magnification.